Gravity is one of the very fundamental forces of the universe, and it's one of the big reasons physics was actually invented. That Isaac Newton, the founding father of the modern day understanding of physics, actually came up with a lot of the physics in response to trying to understand what gravity was and how it worked. And as a result, a lot of the physics we know is very well suited for dealing with gravity. So to start with, let's look at some terms. First of all, position. We know what position is, and in a linear context, we often call it x or y. And then we know something called velocity, and velocity is change in position. And we say for a constant velocity, the velocity equals x. Velocity times time equals x. Or velocity times time equals y. And then we have something called acceleration. And for a constant acceleration, velocity equals time times acceleration. But how do we put that together? Is there any way we can relate position, whether x or y, in terms of some function regarding acceleration? And we can do this. It's a bit of a complicated formula, but it's actually not too bad. And this formula is developed using calculus, so it's too hard to explain. So right now you'll have to take it on faith. If you do a little more physics, you'll be able to understand this a little better. But for now, it's just worth knowing that an object's position is the same as its starting position, which we'll call x sub 0 for original, plus its starting velocity times time, plus 1/2 the acceleration times time squared. Now let's go through this term by term. If x is the position and x original is the starting position, then really what this function is looking at is change in position. If it starts at point 10 and now it's at point 11, that means that you've gone forward 1 point. So that means the rest of this function is devoted to describing change in position. And VO, velocity original, times time, that just says where this object would be if it was going at a constant speed. This goes back to our idea that change in x, the triangle is delta, it means change in, equals velocity times time. This velocity just becomes velocity original, and the time stays the same. So as a result, we can say x equals xo plus vot. But this doesn't take acceleration into account. What happens if there's acceleration? And that's where this term comes from. Now, have you ever seen an object in flight, whether a stone thrown baseball or some kind of rocket? You'll notice it tends to fly in a shape called a parabola. And a parabola is often defined by something squared. So if you wanted to do this in math, you'd say y equals some constant times x squared. And the same is true in physics. We call this constant is 1/2 of acceleration. And that's been determined both experimentally as well as mathematically. And then our function, and then our variable is just time. So 1/2 at squared. So as a result, we can describe the position of an object as x equals xo plus vot plus 1/2 at squared. And if a is positive, for instance, if something's falling downward, that can mean that it's flying and it falls more and more downward. Whereas if x is negative, it can curve in the opposite direction. It starts going up and then gets curved back down again. So whichever way it goes, it tends to form a shape that looks somewhat like this, a parabola. And that makes sense because a parabola is the shape you get when your highest order term is something squared. Now this equation can be used in a lot of different contexts. For instance, imagine that there's a race car, and this isn't a very good race car, but it gets the idea across. If its starting velocity is 0, it's stationary, and it's accelerating forward at 5 meters per second squared, which is about half the acceleration of gravity, then how far will it have gone after 10 seconds? And there isn't a great way to do this without this equation. We can relate acceleration to velocity and velocity to position, but only if acceleration and velocity are both constants. And if acceleration is not 0, then velocity is not constant. So to get around this, we use our newfound equation. X equals xo, and we'll say the original position is 0, plus velocity original, which is 0, times t, plus 1/2, the acceleration is 5, t squared. So x equals 2.5 t squared. T equals 10. We determined that up here. So as a result, our final position is just going to be x is 250 meters. And that makes a lot of sense. I managed to go 250 meters in that 10 seconds because it's coming up to speed very, very quickly. And if it continued accelerating like this, after the next 10 seconds, it'd go way more than 250 meters. It'd actually go more like 1,000 meters, and that's because it's a squared. It's exponential. The longer it goes, the faster the speed of the race car grows, and the even farther it goes. So that's all for this unit. You can do a couple questions on this, and then move on to the next unit.